Example 1 is about sketching the graph of a linear function. In 2015, Christopher Stracer set a new 24-hour cycling record by riding 556 miles in a 24-hour period. The distance he rode over the 24 hours can be represented by a function. Move through the slides to see how to use the key functions to sketch a graph that shows the distance traveled y as a function of time x. Y-intercept. No distance has been traveled when he has ridden for 0 hours. Linear or nonlinear, the graph of the function is linear. Positive for time greater than 0, increasing for time greater than 0. End behavior, as the number of hours he has ridden increases, the number of miles he has traveled also increases. So we start with a basic graph, and before sketching, we want to consider any possible constraints of the situation. It's not possible for Christopher to ride for a negative amount of time or ride negative miles. Therefore, the domain and range are restricted to non-negative x and y values on the graph and only exists in this first quadrant. Again, the y-intercept. There's no distance has been traveled when he has ridden for 0 miles. So the point 0, 0 represents 0 hours ridden and 0 miles traveled. And that is graphed on the coordinate plane at 0, 0. Next, linear or nonlinear. The graph of the function is linear, so it's going to be a straight line. It's positive for time greater than 0, increasing for time greater than 0. The graph is a straight line that is positive and increasing for all hours ridden. The end behavior, as the number of hours he has ridden increases, the number of miles he has traveled increases. So we're going up from left to right. As x increases, y increases. When he has spent no time riding, no distance has been traveled. The more time he spends riding, the more distance will be traveled. And then as a reminder, he traveled 556 miles in 24 hours. So we know that the other point has to be here, which is how we know how steep to make the line.